Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon, Mr.
Okay, thank you. Sit down. We'll continue on with our work on rocks, and today we'll go ahead to looking at the second grouping. I mentioned that there are three main groupings that all rocks can actually be classified under. We have the igneous rocks, the sedimentary rocks, and the metamorphic rocks, correct. We looked at how we can identify igneous rocks from simply looking at the origin. And yesterday we looked at how sedimentary rocks are formed. We found out that there are two different ways or two different sites of which sedimentary rocks are formed. One, the rocks which are formed under the surface, which are referred to as intrusive plutonic sedimentary rocks. And the second site are the extrusive volcanic igneous rocks. Did I say sedimentary? Yes. Okay, I'll make that correction. It's supposed to be igneous. So I'll repeat that again. The first group, according to site, are the intrusive plutonic igneous rocks. And the second group of igneous rocks, according to the site of their formation, are the extrusive volcanic igneous rocks. We are able to actually look at those two different groupings of rocks according to where they are formed, and as well as that according to the crystal size. But let's note that with the information on the crystal size, we need to be a bit more careful, and we need to really understand and know what we are looking for us to be able to note the different crystals in rocks. And usually it is the geologists who are responsible for identifying those different minerals in rocks. Let's go back to the definition of rocks and also look at the other important word that appears in the definition of minerals. And then today we are going to move on to looking at sedimentary rocks and some examples of sedimentary rocks, as well as that, how sedimentary rocks are actually formed. So our task for today, or by the end of the lesson today, you should be able to identify how sedimentary rocks are formed and also be able to look at some examples of sedimentary rocks. Okay, let's look at the definition that we have already from what we covered in the introduction to the work on rocks. From the monitor, definition that was given stated that rocks are simply a combination of one or more minerals which are compact and consolidated together. From the definition, the word mineral or minerals comes in, and to understand what minerals are, because they are what makes up the rocks that we have on the surface and also those that are found under the surface. It tells us that minerals are naturally occurring. That means they occur naturally in nature. They are also inorganic compounds, each with its unique crystal structure and also possessing a definite chemical composition. And note that also minerals are almost always crystalline in form. And that is a definition that we looked at on what minerals are. If we had to make reference to something which could be a little bit more easy for us to understand in terms of the minerals in rocks, then we looked at fruit cakes. The different ingredients that you use for making the fruit cakes can be seen as the different minerals in different rocks. Then we looked at the first grouping, and the first grouping was that of igneous. The definition given for what igneous rocks are: they are rocks formed from the cooling and the crystallization or solidification of magma, which then gives rise to one or more rock types according to the composition of the magma and the size and the site of its solidification. So where magma solidifies, then where it cools, it solidifies and it crystallizes, will give us the igneous rocks. Your homework, you were supposed to look at a flow diagram, and that flow diagram that you were supposed to have constructed should be able to help you differentiate between the two areas of where igneous rocks are actually formed. So if we looked at that information again from the table, and then you can double check with the information you have constructed in your exercise book. Note, on the first column, we have the place where the rock is formed. We're looking at the site. And we found out that igneous rocks can be formed intrusively or they can be formed extrusively. The intrusive igneous rocks are referred to as plutonic igneous rocks. The extrusive igneous rocks are referred to as volcanic igneous rocks. How do we identify the site of their formation, or what would be another way in which we can identify from where have they been formed? We can look at the crystal size. The intrusive plutonic igneous rocks, they tend to have large crystals. We found out the reason yesterday why the crystals are large, and it is mainly to do with the process of cooling. The cooling process is slow, or the rate of cooling is slow, therefore the crystals have had time to develop or grow. Whereas the extrusive volcanic rocks, they tend to have very small or fine crystals, and the reason being that the rate of cooling has been very fast. And because of the fast rate of cooling, they have not had time, the crystals have not, or they did not have time for them to grow or develop. Then we looked at a simple example of an intrusive igneous rock and a simple example of an extrusive volcanic igneous rock. For the intrusive plutonic igneous rock, we said granite was a good example. And for the extrusive volcanic, we said basalt was an example, a good example. When we go back to our definition, the definition to rocks, we saw it was to do with a compact consolidated mass of mineral matter. That's looking at what rocks are. So if rocks are made up of minerals, then if we are looking at a simple example of an intrusive igneous rock, which is granite, then obviously in granite there would be minerals. Three of the main or the common minerals which are found in a rock of granite are that of mica, quartz, and feldspar. Note that mica, quartz, and feldspar are not rocks, they are minerals. Similarly, for basalt, the minerals which are common in a rock of basalt are that of iron, pyroxene, and feldspar. Those were the three minerals which were common that we looked at in a rock of basalt. Okay, your homework, you were supposed to actually look at that information, and then from that you have a flow chart constructed, and that flow chart will show the relationship between the intrusive and the extrusive igneous rock. We also had time yesterday to look at some examples of rocks which are igneous. Granite, we found out that is a sample of an intrusive igneous rock. In the rock of granite, we also looked at the minerals under a microscope, what they would look like, the minerals of feldspar, quartz, and mica. We also had time to look at other minerals, but still on the mineral of quartz. I think most of the students saw that and said chips, potato chips, but that is a sample of what the mineral quartz would look like. Then we looked at other examples. I hope you have also made note of those other examples of igneous intrusive plutonic rocks. Diorite is another example. We have gabbro, which is also another example of an intrusive igneous rock. Then we moved on to looking at some examples of extrusive volcanic igneous rocks. We started off with a diagram or picture on lava. We have basalt. We have already found out that it is an example of an extrusive rock. And from the rock of basalt, the common minerals would be that of feldspar, pyroxene, and iron. The arrows, the red arrows, will show us from the microscopic sample of what those minerals would look like. And then we had other examples of extrusive igneous rock, obsidian being a common one, because in Papua New Guinea we do have also areas or sites in the country where obsidian is mined. Andesite is also another example of a igneous extrusive volcanic rock. Then we looked at pumice. When we were studying volcanicity, we looked at pyroclastics, and you were told that pyroclastics basically looked at all types of materials which are ejected from a volcano during an eruption. A rock which is also released together with all those pyroclastics are that of pumice. And you have a sample of pumice from the monitor. And with that information now, we are going to move on. And what I'd like us to look at now would be the processes which are involved in the formation of the next group of rocks, which are referred to as the sedimentary rocks. But before we move on, is there anyone in the class who might have a question or who may want to ask a question with regards to what we have covered on the igneous rocks? Any questions? No questions perhaps tells us that you have understood everything that we have covered so far. Well done. We'll move on. Okay, we'll move on, and note that now we have found out about the site of the igneous rock. That means where they are formed. We are ready to look at the second or the next grouping. Let's look at those igneous rocks which are actually lying exposed on the surface. Do they sit on the surface forever? Okay, if you say no, then what do you think might happen to those igneous rocks which are formed on the surface? Val, what do you think would happen to it? Okay, you have told me that no, they don't just sit there forever on the surface. Something happens to them. So what happens to them, Val?
They'll be eroded.
Okay, they could be or they can get eroded. Do we all agree with Val that definitely they can get eroded? Yes, definitely. Okay, how about those rocks which are igneous but which have been formed under the surface? Do they sit there forever? What do you think might happen to those rocks which are formed under the surface? Kathy? Francis? No? Ebony? I'm making reference now to those rocks which are igneous that we have looked at, which are formed under the surface. Do they sit there forever? You said no. On the surface, you also said no, they get eroded. Correct. How about those that are under the surface? You told me they don't sit there or they don't stay there forever. So what could happen to them? What could happen to them? Gibbest? Bill at the back? No? So shall we leave it as those igneous rocks that are formed under the surface? They can stay there forever or they remain there forever and nothing happens to them. Okay, so what happens to them if you don't agree then, Kathy?
They'd eventually come up to the surface due to the heat below.
Very good. They'll definitely or eventually come up to the surface, not only due to the heat below, but also through the process of tectonic movements. You remember? Convergence of plates, uplifting, folding, faulting can bring those rocks under the surface out onto the surface. So here goes. All those rocks then, which may be under the surface, may eventually come out onto the surface, and all those rocks which are lying on the surface, they definitely will be eroded. But before the process of erosion takes place, note that those rocks then will be attacked by the elements of weather. And when we look at the elements of weather, they are things like the water, the rain, the wind, the ice, temperatures, different temperatures, etc. All of those, they will attack the rocks which are on the surface. Then, when they attack those rocks on the surface, what happens to those rocks then? They will break up, yes. The elements of weather attacks those rocks. When those rocks are attacked by the different elements of weather, then they will definitely break up. The breaking up of those rocks then, there is a process that we actually should look at or must know about, and that process is referred to as weathering. And later on, the next subtopic or topic that we will move to will be that of denudation. And when we look at denudation, that's when the processes of weathering and erosion will come in. But we are looking at the stages in the development of the second group of rocks now, which are the sedimentary rocks. All rocks lying on the surface get to be exposed to the elements of weather. They are attacked, and upon attacking those rocks, then they get to be broken. The process or the term that we use to describing the breaking down of rocks is weathering. Weathering then can take place in the form of physically or mechanically. Weathering can be chemical, and weathering can be biological or biotic. In other words, all those rocks that are on the surface, they can be broken down physically or mechanically. They can be broken down chemically, and they can be broken down biologically. We will look at each of those processes again later on our topic on denudation. But that's how the rocks could be broken down. Okay, now we note that all those rocks are broken down. The broken down rocks or materials, do they sit where they have been actually collected and stay there? Or what do you think could happen to them next? If the rocks are broken down, do they sit there forever? No, they will have to be moved. So those rocks that have been broken down, the materials don't stay there forever. They will move. And the moving of those broken down material, there is a term that we use to describing it. If weathering is to do with the breaking down of materials, what do you think would be the term that we use to describing the movement of those broken down materials? Gao, what do you think is the term? Okay, if weathering refers to the breaking down of rocks, what would be the term that we can use to describe the movement of those materials which have been broken down?
Erosion.
Erosion, very good. Note that erosion now takes place, and in erosion, note the definition to erosion. It is the transportation, which is the movement, as well as the further breaking down of materials. So those rocks that have been broken down already, they move. And while they are moving, they are also further being broken down. So we can say that erosion is both transportation and weathering. You're following? Okay. So erosion takes place. And when the rocks have been eroded, there are three important agents that help in the movement or the transportation and the further breaking down. What are those three agents of erosion that you might have learned about already? Catherine, tell me, what are the three agents of erosion that help or aid in the transportation and the further breaking down of materials? Shelley, the three agents of erosion? Shelley? Silo, at the back? Three agents of erosion?
Wind, water, and ice.
Wind, water, and very good. So we have the three agents of erosion, which is wind, water, and ice, will help to transport, and while transporting, they will also help to further break down those materials. Okay, we move on. All those materials that have been transported, they will continue on to move forever and ever. Is that true? What would finally happen to them? They will get to be settled. Okay, good. When they are settled, the term that we also use to describing the settling of those materials is, Mason?
Deposition.
Very good, deposition. So deposition now comes in. So let's look at the way in which those material which have been carried out will be deposited. Okay, they get to be deposited, those different materials, but they may be deposited in what we call different layers. From what we have studied already, what is the term that we use to describing the different layers of sedimentary rocks? Francis.
Strata.
Very good, strata. So we have strata to describe the different layers of sedimentary rock. Francis, while you are still at that, what is one layer of sedimentary rock referred to as? We say strata is 1, 2, 3, 4, 5, or more than one layer. How about if it's only one layer? No? Okay, let's check the information from the monitor. He's given us definitely the materials which have been settled would usually be settled in different layers which are referred to as strata. And if we are making reference to only one layer, then that one layer is referred to as stratum, yes. So the stratum is one layer, strata more than one layer. Okay, note the way in which this particular strata has actually been constructed or put up for you. You note the oldest material that have been actually eroded get to settle at the bottom. Then over time, the next layer is actually settled and compact on top of what was already there. Over time, the next layer and the next and the next until you have what we call a compact consolidated mess, of which then would make up our next grouping of rocks, which are referred to as the sedimentary rocks. Look at some examples of sedimentary rocks, of which you will be required to make note of later on. You could have at the low or the first strata or stratum, you could have rocks which are of, maybe they are examples of gypsum. Gypsum is a sedimentary rock, and this layer here might be made up of rocks which are mainly gypsum. Then you have the next layer, which might be, maybe for example, it could be shale. Shale is an example of a sedimentary rock. The next layer you might have limestone. The next layer you might have conglomerate. The next layer you might have sandstone, and etc. But here we are looking at an example of a strata, and as well as that some examples of sedimentary rocks. Another important thing we need to know about the strata, always the oldest layer would be at the bottom and the youngest layer would be at the top. And also note that the processes whereby one strata is formed or one stratum is formed and etc. It doesn't take like today one layer, tomorrow the next layer, the next day the next layer, no. This is referring to geological time, and it will take hundreds to millions of years for the formation of those different layers. Classic example, if we look at the Grand Canyon. You heard about the Grand Canyon? Yes, if you look at the Grand Canyon, maybe later I'll show you maybe a photograph or picture of the Grand Canyon. You will see the different layers of rocks which have been laid over millions of years and the general structure of such a feature. Okay, we'll move on. The definition now to what sedimentary rocks are, a simple definition from the process we have looked at, is simply rocks, sedimentary rocks are rocks which are formed from the accumulation of weathered and eroded materials and are usually deposited in layered sequence. Do you think the definition is simple enough for you to understand? Okay, I'll go through it again. We've looked at the processes on how a sedimentary rock could be formed, and we found out that sedimentary rocks are formed from the accumulation of weathered and eroded materials and are usually deposited in layered sequence. Okay, note two important facts also about sedimentary rocks. They could usually contain fossils, and sedimentary rocks are usually non-crystalline. Those are two important facts we need to remember with the definition on sedimentary rocks. Any queries or questions so far from what we have covered? Okay, are sedimentary rocks the only rocks that go through the processes which I have explained? The process of weathering and erosion and deposition? Are sedimentary rocks the only rocks that go through those processes? No. Metamorphic rocks could also go through the same process, and also igneous rocks can go through the process. Similarly, those sedimentary rocks which are already formed, they can also go through that process for their further breaking down, settling, and etc. So this process that I have looked at goes or is, it applies for all the three different groupings of rocks, the sedimentary, metamorphic, and igneous. Okay, if there are no questions, let's look at some samples of sedimentary rocks before we move over now to three activities that I'd like you to complete. Some examples which have been actually scanned and put up for you. Conglomerate is an example of a sedimentary rock. It comes under the heading on Clastic. Later on, when we look at different groupings of rocks, and in grade 12, we are going to look at sedimentary rocks that are formed chemically under one group, sedimentary rocks that are formed organically under one group, and sedimentary rocks that are formed biologically under one group. But for now, we look at it generally. Clastic sedimentary rocks, example, conglomerate, sandstone, silt stone, and mudstone. These are some examples you could make note of, or you could list also. A chemical sedimentary rock formed chemically is the sample or example of limestone. Okay, so limestone is a sedimentary rock, but it is formed chemically. Remember I told you, weathering involves physical or mechanical, it involves chemical, and it also involves biotic or biological. So any rocks which are broken down chemically will form the chemical sedimentary rocks. And an example of such is the rock of limestone. Organic sedimentary rocks, coal. What is coal actually made from or of? Generally from plants, remains of plants mainly, yes, over time. Remember grade 10, we did work on the Carboniferous period? Yeah, 360 million years ago, where deposits of coal were evident, and they were formed mainly from those forests which actually got destroyed and then kept in layers over millions of years to have given us the deposits or samples of coal. You have the bituminous coal here, and here you have oil shale. It's solid to give us the rock, which is oil shale. Then we look at the activities now. For the three activities I'd like you to work on. The first one, I mentioned that one of the important properties that sedimentary rocks might have is that they can contain fossils. Can you explain why fossils can be found in sedimentary rocks and not in igneous rocks? That's the first activity. Number two, can you give an example of a combustible sedimentary rock which is formed from plants? Do you know what combustible means? Yes. Some students do not know. For those students who know what combustible is, would you like to simply explain it to the other students so that they can be able to maybe give an example? Someone was nodding their head saying that they knew. Mason. Okay, thank you, Mason. Can you tell us what combustible means in simple terms?
Rocks that can be burnt and used as fuel.
Very good. That's it, simple. That can be burnt and used as fuel, yes. So here you are asked to give at least one example of a combustible sedimentary rock formed from plants. And the third one, Give also an example of a sedimentary rock that you know of that could be formed from animals. Okay, you have the task now, maybe 3 to 5 minutes for the completion of those 3 exercises. If you want to discuss with the person sitting next to you, you can do that and have your answers written in your exercise book. Okay, we'll look at the correction. We start off with the first one. Ovio, can you explain why fossils can be found in sedimentary rocks and not in igneous rocks? Ovio. Frank, can help Ovio. Why do you think fossils can be found in sedimentary rocks but not in igneous rocks?
Igneous rocks do not contain any fossil because the fossils when they've been burnt out by the heat during the formation of igneous rocks.
Very good. How about the sedimentary rocks? You've done the igneous part well. How about the sedimentary? Would someone like to actually help? Thank you. Okay, while the mic is coming across, Frank has said that for the igneous rocks, it would be impossible for the fossils to actually be kept in them because of the heat that the igneous rocks would have gone through in their formation. Well done, and I've also accepted or agree with his answer. How about the sedimentary rocks?
Sedimentary rocks contain strata or layers and can contain fossils for millions of years.
Okay, she's made a point here of which we can actually improve on, and that is the fact that sedimentary rocks, they usually contain layers. And along or between the layers, the word that we use to describing one maybe section separating a strata from the next is the bedding plane. Along where the bedding plane is, the fossils can actually be preserved or kept in and compressed and compact over millions of years. And that is what makes the difference in terms of why one can tend to contain fossil while the other cannot contain fossils. Very good. Okay, let's look at the next question. Anyone would like to give us an example of a combustible sedimentary rock? Dorothy? A combustible sedimentary rock? No? Francis?
Coal.
Very good. Coal. Coal, combustible. It is sedimentary rocks from plants. Well done. How about an example of a sedimentary rock from animals? Trowen. It's going to give us an example of a sedimentary rock formed from animals. Limestone. Limestone. We said that limestone was a chemical. Sedimentary rocks from animals. No? Okay, someone else would like to actually give us maybe another example. Moses? Let me give you a clue. Perhaps something that you would find in the sea. Yes, someone has already given me the word before I used it. Something which is maybe sedimentary formed by animals or from animals in the sea. It would be coral, yes. Coral would be a good example. So here we have coral, an example, and here we have coal as an example. Okay, that will also bring us to the end of our lesson. But note, can you quickly make note now of your homework? Your homework, remember we looked at some examples of sedimentary rocks. What I would like you to do is see if you can find other examples that we did not look at or that was not mentioned from our lesson today that are classified as sedimentary. So you're looking at other examples of sedimentary rocks and you make a list of those for your homework. Okay, class, if you can now stand up. To the pilot teachers, our keyword for lesson 54 is strata. Good afternoon and thank you, students.